Alright students, we're here and we did a bunch of mid-segment stuff yesterday, and probably the most important part of mid-segments is the word mid, and even segments, because it's a segment that connects midpoints. It's a very well named word. Alright, so warm up. This is from Phase 1 stuff. This is from yesterday, so this should seem like a review. You should know this stuff. If P is the midpoint of AB, so again, let's just kind of guesstimate. That's P somewhere right there. Q is the midpoint of BC. Alright, so I connected them. And R is the midpoint of AC. Again, I'm not doing exact stuff. I'm just kind of guesstimating so I can visualize what's going on. Alright, what segment is parallel and half the length of AB? Alright, so again, by actually kind of guesstimating, I can visualize exactly what's going on. So AB is clearly right there. RQ will be the answer. Alright, because remember, I like this problem because it basically just gives you the definition of the mid-segment theorem. Alright, RQ is parallel to AB, and then RQ is half the length of AB. So you could write it like this, or you need to times RQ by 2 to equal AB. Okay, so remember, mid-segments are parallel to the opposite side, and they're half the length of the opposite side. So that's kind of a good review, because now we're going to jump in this. Alright, solve for the indicated variable. You may assume that all line segments within a triangle are mid-segments. Alright, so what I like to do, what I prefer, and this is a piece of advice, is always just multiply mid segment by 2. Right? You can technically divide the opposite side by 2, but then you run into fractions and decimals at times. Alright, so all I'm going to say is, well, I need to take this to get to 6, to get 6 to be the same as x, I got to multiply it by 2, so I'm going to just do 2 times 6 equals x, or 12 equals x. That's it. That's probably one of the most basic problems we can encounter. Here, again, remember, I like to say multiply the mid-segment by 2. Alright, so I'm going to get 2 times 7 equals 2x plus 3. Alright, I'm going to get 14 equals 2x plus 3. So I said most of the time when you do it this way you won't encounter fractions or decimals, but not all the time. It doesn't matter the way you did this problem, you'd get a decimal. I know sometimes students get spooky or spooked out by decimals. You could say that's a good answer, or you could say 5.5. Those are the same number. 11 over 2 is a reduced fraction, or 5.5, or you could even say 5 and 1/2. Those are all the best answer. Me, I'm lazy, I just keep it like that. I'm a fraction kind of guy.